This diagram illustrates a water-cooled chiller system used in an HVAC, heating, ventilation, and air conditioning setup to provide chilled water for cooling an indoor space. Let's break down the different components and their functions. 1. Electric chiller. Evaporator. This is where the cooling process begins. Chilled water from the air handling unit, HU, returns to the evaporator. Inside the evaporator, a refrigerant absorbs heat from this returned water, causing the water to cool down and the refrigerant to evaporate, turn into a gas. The cooled water is then sent back to the AHU as chilled water supply. Compressor. The gaseous refrigerant from the evaporator is compressed, which increases its temperature and pressure. This is an energy-intensive part of the cycle, typically driven by an electric motor. Condenser. The hot, high-pressure gaseous refrigerant from the compressor flows into the condenser. Here, it rejects its heat to a separate, hot water loop coming from the cooling tower. As the refrigerant loses heat, it condenses back into a high-pressure liquid. Valve. Expansion valve. The high-pressure liquid refrigerant then passes through an expansion valve, often a thermostatic expansion valve, or TXV. This valve reduces the pressure of the refrigerant, causing it to cool down significantly before it re-enters the evaporator to absorb more heat, completing the refrigeration cycle. 2. Cooling tower system. Hot water. This loop carries heat from the chiller's condenser to the cooling tower. Cooling tower. The hot water is sprayed down over a fill material inside the cooling tower. Air in from the surroundings is drawn to the tower by a fan. As the hot water comes into contact with the cooler air, some of the water evaporates, which is a highly effective way to reject heat to the atmosphere. Cool water. The cooled water collects at the bottom of the cooling tower and is pumped back to the chiller's condenser to pick up more heat. Air out. The warm, humid air resulting from the evaporation exits the top of the cooling tower. 3. Air handling unit, AHU. Chilled water supply. The cold water from the chiller's evaporator is pumped to the AHU. Coil. With fan inside the AHU, the chilled water flows through a coil. A fan draws in a mixture of outdoor air and return air from the conditioned space. Supply air. As the air passes over the cold coil, it is cooled and dehumidified. This cooled air, now called supply air, is then distributed through ductwork to the various rooms or zones within the building. Return air. Warm air from the conditioned space is drawn back into the AHU as return air. Relief air. Excess air from the building or a portion of the return air may be exhausted as relief air to maintain proper building pressure. Outdoor air. Fresh outdoor air is mixed with the return air to ensure adequate ventilation and indoor air quality. In summary, the entire system works as follows. The chiller produces chilled water by using a refrigeration cycle to transfer heat from the building's water loop to a condenser water loop. The cooling tower rejects the heat from a condenser water loop to the atmosphere through evaporation. The air handling unit uses the chilled water to cool and dehumidify the air that is then supplied to the building's occupied spaces. This integrated system efficiently manages the temperature and humidity of a building by continuously removing heat from the indoor environment and dissipating it into the atmosphere.